All right, so we're going to discuss logs in this video, and these are just going to be the basics of it. So to start, just a general form of a log. Log base A of x is equal to b. We can go ahead and rewrite our log in exponential form, where we take our base of a and make that our base there, and put it to the power of what we have equal to, which is b, and then set that equal to our argument, or what's inside of our parentheses here, which is x. And in this example below, we're just going to go ahead and convert this from log to exponential form. So our example, we have log base of 5 of 125 is equal to 3. And I'm going to write this now into exponential form to make sure that this works. So I'm going to take my 5 here. So it'd be 5 to the power of what we have equal to 3 is equal to 125. And if we went ahead and calculated that, 5 times 5 times 5, or 5 to the power of 3, is equal to 125. So that's converting from log to exponential. And this can also go in the opposite direction. So if we look at this example here, I have 7 to the power of negative 5x equals 1.25. So I can rewrite that as log of base 7 of 1.25 is equal to negative 5x. And that's just converting from one form to the other. We're not solving anything here. We're just going ahead and converting things. So now we're going to go ahead and look at examples where we have to evaluate a log. So right here we have log base 4 equals, or log base 4 of 32 equals x. And so what we can do here is rewrite this in exponential form. So I will have 4 to the power of x is equal to 32. Now, there's nothing, no integer that I can plug into x right here that would give me 32. So I'm going to convert this so that it will have the same base. And a base that 4 and 32 would both share would be 2. So I can rewrite 4 to the power of x as 2 to the power of 2 times x. And then that can be equal to 2 to the power of 2, 4, 8, 16, 32 to the power of 5. And then now that I have bases that are the same, I can set my exponents equal to each other. So I'll have 2x equals 5, and then divide both sides by 2. So x would be equal to 5 halves. So that's just evaluating my log there. And then lastly, I have another example of evaluating a log, and this one's going to be a little bit different. So I have a log base 5 of 19 is equal to x. So I would have to go ahead and see if I can do anything with that in exponential form. So I can write that as 5 to the power of x equals 19. And so we can try like we did last time, but there's no base that 5 and 19 both share. So if that's the case, on questions like this, we would have to use our change of base formula. And let's say our change of base formula is going to be log of base b times a is going to be equal to log a divided by log b. So I'm going to go ahead and do what we have here and plug everything in. So in this case, my log a would be log 19 divided by log of my base b, which is 5. Now we could go ahead and simplify this further, but I don't have a calculator handy right now. So we would just leave this on this form right here. But if you did have a calculator, you would just go ahead and plug this in, and then whatever you would get would be equal to